A double-acting hydraulic actuator is called double-acting because it uses hydraulic fluid pressure to both open and close a valve. A double-acting hydraulic actuator consists of a cylinder, a fluid port at the base of the cylinder, a second fluid port at the top of the cylinder, a piston, and a piston rod, which is connected to the valve disc. Fluid can enter the cylinder through either of the two ports to move the piston up or down. In this example, if fluid enters through the top port, it pushes the piston and piston rod down to close the valve. An equal volume of fluid is bled through the lower port. When fluid flow is directed into the lower port, it causes the piston and piston rod to move up, opening the valve. At the same time, an equal volume of fluid flows out of the upper port of the cylinder. When the flow of fluid is stopped, fluid is trapped on both sides of the piston, and the piston is held in place by the trapped fluid. The piston can be positioned anywhere in the cylinder by controlling the amount of fluid entering the cylinder through one port and bled from the cylinder through the other port. On a piping system diagram, a double-acting hydraulic actuator may be represented by this symbol. A double-acting hydraulic actuator is called double-acting because it uses hydraulic fluid pressure to both open and close a valve. A double-acting hydraulic actuator consists of a cylinder, a fluid port at the base of the cylinder, a second fluid port at the top of the cylinder, a piston, and a piston rod, which is connected to the valve disc. In order for a double-acting hydraulic actuator to accurately position a valve, the amount of fluid entering the cylinder and bled from the cylinder has to be accurately controlled. The device selected to do this job is usually a pilot valve, or as it's sometimes referred to, a spool valve. To see how a pilot valve controls a double-acting hydraulic actuator, we'll use this simplified illustration. This is the actuator, this is the pilot valve, and these are the fluid lines that connect them. The valve is called a pilot valve because it guides or controls the flow of hydraulic fluid to and from the actuator. A pilot valve consists of a valve body, solenoids here and here, a spool, a spring at each end of the spool, a hydraulic fluid supply port, two hydraulic fluid ports to the actuator, and two hydraulic fluid vent ports. The pilot valve is operated by the solenoids, or electrical coils, which respond to signals from a controller to position the spool. In this example, one solenoid is attached to the top of the spool, and one is attached to the bottom of the spool. When both solenoids are de-energized, the springs return the spool to a neutral or centered position. Right now, both solenoids are de-energized. The spool is in a neutral position, blocking the fluid lines going to the actuator cylinder. This holds the actuator's piston in place. When the lower solenoid is energized, the spool is pulled downward. With the spool in this position, hydraulic fluid is supplied through this line to the actuator. The fluid enters the actuator cylinder at the bottom, pushing the piston up and opening the valve. At the same time, fluid is forced out of the top of the cylinder through this line, back through the pilot valve, and out through the vent port back to the hydraulic fluid supply. The filling and venting of the actuator cylinder is reversed by de-energizing the lower solenoid and energizing the upper solenoid. When the upper solenoid is energized, it pulls the spool up, blocking the upper vent line and the path for supply fluid to this line. Hydraulic fluid is now supplied to the top of the actuator cylinder, pushing the piston down and closing the valve. The fluid below the piston is vented through this line, back through the pilot valve, and out through this vent port back to the hydraulic fluid supply. The piston can be held in place by de-energizing the upper solenoid. This allows the springs to return the spool to a neutral position and blocks the fluid lines to the cylinder, holding the piston and the valve in position. Pilot valves and other devices used with hydraulic actuators are often separate from the actuator. However, in some actuators, all the components may be part of a single unit. On a piping system diagram, a pilot valve is often represented by this symbol. When the upper solenoid is energized, it pulls the spool up, blocking the upper vent line and the path for supply fluid to this line. Hydraulic fluid is now supplied to the top of the actuator cylinder, pushing the piston down and closing the valve. The fluid below the piston is vented through this line, back through the pilot valve, and out through this vent port back to the hydraulic fluid supply. Two problems commonly associated with hydraulic actuators are contamination of the hydraulic fluid and hydraulic fluid leaks. Hydraulic fluid can become contaminated with dirt, water, or other foreign substances. Some contaminants can corrode the actuator and cause the piston to stick inside the cylinder, affecting the positioning of the valve. Contaminants could also collect inside the pilot valve and prevent the pilot valve spool from shifting correctly. Or contaminants could block the flow paths in the pilot valve. In either case, the pilot valve would not operate correctly, and the actuator would be unable to position its valve correctly. If you notice that a hydraulic actuator is operating sluggishly, it could mean that the fluid is contaminated with water or some other foreign substance. When water is mixed with hydraulic fluid, the mixture can turn into foam. This foam causes the actuator's piston to have a spongy movement, which can cause problems with valve positioning. Operators may be able to detect water contamination by looking at the hydraulic fluid. This can usually be done at a sight glass on a hydraulic supply reservoir. Hydraulic fluid is normally clear. However, when it's mixed with water, the fluid becomes milky. Water can enter a hydraulic system from leaks in many kinds of equipment. Hydraulic fluid can become contaminated with dirt, water, or other foreign substances. Some contaminants can corrode the actuator and cause the piston to stick inside the cylinder, affecting the positioning of the valve. Contaminants could also collect inside the pilot valve and prevent the pilot valve spool from shifting correctly. Or contaminants could block the flow paths in the pilot valve. In either case, the pilot valve would not operate correctly, and the actuator would be unable to position its valve correctly. If you notice that a hydraulic actuator is operating sluggishly, it could mean that the fluid is contaminated with water or some other foreign substance. When water is mixed with hydraulic fluid, the mixture can turn into foam. This foam causes the actuator's piston to have a spongy movement, which can cause problems with valve positioning. Common sources of water leaks into hydraulic systems are heat exchangers. Many hydraulic systems have some type of heating system on the hydraulic reservoir to keep the fluid warm so it'll flow smoothly. In many cases, steam is used to heat the fluid. If a steam leak develops in a heater, the fluid will become contaminated with water. Heat exchangers that are used to cool hydraulic fluid can also develop leaks that can cause the cooling water to leak into the hydraulic fluid and contaminate it. Another problem that often occurs in hydraulic actuators is hydraulic fluid leaks. When a fluid leak is discovered, it should be reported to the appropriate personnel as soon as possible. Some types of hydraulic fluid are flammable, and a leak near hot equipment can present a fire hazard. Also, hydraulic fluids are slippery, so any accumulation on the floor should be cleaned up. In this topic, we discussed how different types of hydraulic actuators operate, and we saw how a pilot valve is used with a hydraulic actuator to control the actuator and valve position. We also saw how to identify some actuator problems. Now let's try some practice questions.